Hi, in this quick video, we're going to be talking about triangles as well as the Pythagorean theorem. Now, you might have heard a lot of these words before, but it's important to review because we're going to use them quite often. So, triangles can be named based on their angles or their sides. If we're talking about their angles, they're acute, obtuse, or right. So, if we've got all acute, it's acute. If we got an obtuse, it's obtuse. If we got a right, it's right. Pretty straightforward. Now, acute triangles have a very special case called equiangular, where all the angles are the same. So each one is going to measure 60 degrees because every triangle has exactly 180 degrees. So if they're all the same, they all got to be 60. Uh, so equiangular triangles are acute triangles, but they're extra special. In terms of their sides, there's only three options. It's either equilateral, where all the sides are the same. Isosceles means that two sides are the same. And scalene means no sides are going to be the same. Now, so you know, for triangles, if it's equilateral, it's got to be equiangular. So that's true for triangles. But in this goofy shape here, where there are more sides. Equilateral and equiangular do mean different things, but in terms of triangles, if we're equiangular, we're equilateral. If we're equilateral, we're equiangular. Now, something I'm sure you have learned before is this cool theorem. It's called the Pythagorean Theorem, made by Pythagoras and his cult of Pythagoreans, where a squared plus b squared equals c squared. Or really, the leg of our triangle plus another leg of our triangle should equal the hypotenuse of our triangle. So if this is a right triangle with a 90-degree angle right there, we can take the two legs. The legs touch the 90. So that's true for our legs. So 3 and 4 touch the 90. So we would say 3 squared plus 4 squared is going to get us this, the hypotenuse. The hypotenuse is opposite the 90. So 3 squared plus 4 squared is going to equal x squared. So 3 squared plus 4 squared, that's 9 plus 16 equals x squared. 25 then equals x squared. So in order to solve, we would square root both sides. So the square root of 25 equals the square root of x squared. The square root and the squared cancel each other out, so we're left just with a 5. The square root of 25, when we're doing this solving step, we get plus or minus 5. But for the length of this thing, we only need positive. So x has to equal 5. Our algebra says it could be plus or minus 5, but in terms of our shape over here, our side lengths are always going to be positive, so x has got to equal 5. In this example over here, here's my right angle. These are my two legs because they touch the 90-degree angle. So this time I've got to do x squared plus 4 squared equals my hypotenuse. My hypotenuse is opposite the 90, so right over here. So this equals 8 squared, and now I got to solve this equation. So I got x squared plus 16 equals 64. Got to subtract 16 from both sides, so x squared equals 64 minus 16, which is 48. And then I would square root both sides. So x squared equals square root of 48. There we go. So x equals plus or minus. Now the square root of 49, that's nice, that's 7. But the square root of 48, not so nice. So I'm just going to leave it the square root of 48. We could simplify that down if you care to know. It's plus or minus 4 squared to 3. But that's not the thing that I'm testing you on for this video. Mostly I want you to be able to get to that square root of 48. But we only need positive. So x is going to be the square root of 48. And that's our answer. Be very careful that your legs are the ones being added together. They touch the 90, and make sure the hypotenuse is on the opposite side from the 90. I've got a few more bonus examples here just to make sure that we really got this Pythagorean theorem thing down. It's very important. So right here, I can identify my right angle as right here, where the little corner is. So this is a right triangle. I've got 3 and x that are touching it. So I need to do 3 squared plus x squared is going to equal 7 squared. And I just need to solve that equation. So that's 9 plus x squared equals 49. Subtracting a 9 from both sides, we get x squared equals 40. And then we need to square root both sides. So square root equals the square root of 40. So x equals plus or minus the square root of 40. If you care to know the simplified radical, you could just leave it as this 40. If you do simplify it, it's plus or minus 2 square roots of 10. We only need positive, so x is going to equal 2 square roots of 10. Oh, shoot. I'm going to write the square root of 41. Next one, I've got my right angle right here. The ones that are touching that right angle are 14 and x. So I've got 14 squared plus x squared is going to equal 20 squared. 14 squared is 196 plus x squared equals 400. Subtracting 196 from both sides, x squared equals 204. We would square root both sides. X equals plus or minus the square root of 204. Or you could say x equals plus or minus 2 square roots of 51. But I'm just going to do this one because that one's easy. I just need the positive case because our side lengths have to be positive. So x equals the square root of 204. Final example here. So we've got our triangle. Here is our corner. So that is our right angle. Our legs are right next to the right angle. So that's going to be 6 squared plus 4 squared. Our two legs are right there. Our hypotenuse is on the opposite side. So that's going to equal x squared. And now I just need to solve for x. This will be a nice easy one. So we got 36 plus 16 equals x squared. 36 plus 16 is 52. And then I need to get that x by itself, so I'm going to square root both sides. So we get plus or minus the square root of 52 equals x. We could simplify that radical as 2 square roots of 13, or you could just leave it as the square root of 52. I don't care. I'm just going to write my answer as the square root of 52. And that is it for this video. Remember, the two legs are adjacent or touching that right angle, and our hypotenuse is opposite of that right angle. Thanks for watching. Bye-bye.